Diagram shows a quadrilateral OACB in which OA equals 4A, OB equals 3B, BC equals 2A plus B. Find AC in terms of A and B. So to get from A to C, I'm going to have to use this route here. So A to C is A to O plus O to B plus B to C. A to O is minus 4A. It's going back along through the vector. O to B and B to C. Well, if I simplify that, minus 4A plus 2A is minus 2A. 3B add B is plus 4B. The point P lies on AC such that AP to PC equals 3 to 2. Point Q is such that OPQ and BCQ are straight lines. I'm just going to add on some lines here. OPQ, I'm just going to extend it because it's going to need to go through, it needs to join the extended line from B to C. So let's extend the line B to C. So that point where they cross is Q. Using a vector method, find OQ in terms of A and B. Give your answer in a simplest form. Show your working out. So I'm just thinking O to Q is an extended version of O to P. So it's like Y times O to P. Can you see, like, they're parallel and they go through the same point, aren't they? So they're going to be the same vector, but with different scalar quantities, if that makes sense. So with these vector questions, when we've got all these unknowns, let's see if we can find O to Q in a different way. And then we can start working out our unknowns. That's kind of the key to answering these questions. So I've just kind of looked at that way from O to Q. Why don't we do this way as well? So O to Q is O to B plus B to Q. O to B is 3B. Now we're in a similar situation here to the OPQ. It's like a scalar quantity, so I'm going to use a different letter X, of your BC. Because it's an extended version. So it's like that. So many times 2A of 2A plus B will give you BQ, but we don't know how far away along. Because we've got O to Q in two different ways, let me just write this actually as part of our, we need to actually work out OP, which we don't know yet. Okay, but what we do know is we know A to C. Right, hang on. So O to P is O to A plus A to P. O to A is 4A. Now A to P is 3/5. It's got the ratio 3 to 2. So 3/5 of the way along A to C, which we do know. So it's 3/5 minus 2A plus 4B. Now you could use fractions or decimals here. I'm going to use decimals because it's going to be a terminating decimal. So I'm actually going to just expand these brackets here. So 3/5 is 0.6 times minus 2a is minus 1.2a. And then 3/5 is 0.6 times 4 is 2.4b. So let me just add this in here. That is my a to p minus 1.2a plus 2.4b. Don't really need that plus that. Let's just simplify that. Four minus 1.2 is 2.8. Running out of space a bit here, so I've just going to carry on in this box. So now we have our O to Q in two different ways and put them equal to each other. So we know y times 2.8a plus 2.4b is equal to the other OQ, which is 3b plus x times 2a plus b. Now we're going to equate coefficients of a first, because we've got so many unknowns still. Let's equate coefficients of a. If I expanded these brackets here, I'd have 2.8ya plus 2.4yb. So my coefficient of a would be 2.8y. And on the other hand side, if I equated coefficients of a and I expanded the brackets, I'd have 3b plus 2ax plus 2xb. We're equating coefficients of a, so my coefficient of a would be 2x. Now I'm also going to equate coefficients of b. Again, if I expanded the brackets on the left-hand side, my coefficient of b would be 2.4y. On the left-hand side, I'd have 3b plus xb. So it would be 3 plus x. So now I have some simultaneous equations. I am going to, I think I'm going to make x the subject, sub it into the bottom equation. So I'm going to make x the subject here. So I'm going to divide both sides by 2, which give me 1.5y is equal to x. I'm going to sub that into the bottom equation. So 2.4y equals 3. Add 1.4y. So let's just make y the subject here. Let's take 1.4y off both sides, which gives us y is 3. Okay, I'm going to finish this question off in the corner. So now I know that y is 3. I can substitute that back into here. So you see here I've got my y. So OQ is 3 times 2.8a plus 2.4b. And if I expand those brackets, 3 times 2.8 is 8.4a. 3 times 2.4, 7.2b. That is my final answer. That is the vector OQ.